Hey, well, welcome, Suzanne. There's Rhonda. So, welcome aboard. And this is our last session for the grade fives, as space is our last organizing idea, unless you're going to be joining us for grade six. This is it. We've done them all, and you'll have them all. And now you kind of got the better part of the half year now just to kind of unpack everything that we had available to you and see where they all fit in. So welcome aboard. My name is Chris Arski. I am one of the ARPDC consultants with the CART Consortia, and I have the best partner to plan with, and that would be Ted, and I'll let Ted introduce himself as well.
Thanks, Chris. I was may not be the best partner, but I enjoy working with Chris for sure. We do have a lot of ideas banging off each other, so it's really nice. Anyways, welcome everyone. My name is Ted Zeroni. I am with the Edmonton Regional Learning Consortia, and looking forward to being with you this afternoon. And thank you for being here with us.
Okay. Some of the slides that you see today may be if you've been joining us all the way along, and because we're recording this and we know that we have a group that are just joining us for space, they may or may not have seen some of these pieces. So just bear with us. We're not going through the whole gambit and the preamble of stuff that we've done before, but just so that we're kind of um, at least having the common language and knowledge of where we want to go. So in our particular acknowledgements throughout all of our organizing ideas up until now, we have been making sure that we're just basically been trying to tie in some topic that is in the organizing idea or that there's a relation to the organizing idea. And because star science is very important to Indigenous peoples, it was very easy to find some that we could link in here. Now, I picked a different one for tonight so that, first of all, Rhonda wouldn't have to listen to the same one again, but also because it just tied into what we're unpacking today in grade five, a little bit differently than it would in grade four. So we're actually going to watch this one. It's only about a minute and a half. It's not long.
So the story we're going to relate to you today is called Atima Chagasak, the dog stars. And it refers to the group of stars that's known as Ursa Minor, or the Little Dipper in the sky with the anchor star Polaris. For the Cree people, we look at that group of stars and we call it Atima Chagasak, the dog stars. And the story tells us how human beings acquired dogs. Because at one point, human beings didn't have dogs. So they didn't have no early warning systems in their camps at night. Nothing to bark and make noise and tell them that something was coming. So what they do is they assign night watchmen to watch over the camps at night. So these was various young men that would stay up all night and would look after the camp and make sure nothing got in or nobody got in. But of course, being human beings, these young men, at times they got hungry in the middle of the night and they decided they had to go eat. So they'd go eat and they'd leave their post, and as they left their post, then animals would get into camp, invaders would get into camp, or maybe they'd eat too much and they'd get upset stomach and they'd have to run to the washroom, and again they'd leave the camp open. Or maybe in the middle of the night they'd hear a psst, psst, and their honeys would come looking for them, and then they'd totally forget what they're doing, and then they'd again forget their jobs. And so this went on for years and years and years. The camps were invaded, and destruction happened, chaos happened, even death happened. And after occurring for years and years, one of our brothers, Nishdesh Mayagan, our older brother, the wolf, he watched us and he felt sorry for us. He said, those human beings are pitiful. I'm going to send 2 puppies to live with them. So Maigan, he sent 2 puppies to live with us. So 2 little wolf puppies went to live with the human beings. But Maigan had 2 younger brothers. And one of his younger brothers was Mistataganis, the coyote. And Mistataganis thought, my Nistes is sending puppies. My older brother is sending puppies, so I'm going to send puppies. And so Mistataganis, the coyote, he sent 2 puppies also. And not to be outdone, the youngest brother, Magasu the fox, he said, okay, my brothers are sending puppies, I'm sending puppies. So the way it turned out, 2 sets of 3, 6 dogs went to live with 6 puppies went to live with the human beings. And these 6 sets, there was 4 sets of 6. They went to live in the 4 directions of the world with all the humans beings throughout the world. And from those sets of dogs in each of those directions, we get all the dogs of the world. And the interbreeding of the species, that's how we acquired the dogs, and the taming of those brothers and sisters, those relatives of ours. And science says that this is actually how we did get dogs, with the interbreeding of species and the taming of the species. So that's how dogs were acquired throughout the world. And there was a study done in northern Russia, in Siberia, back in 1920 and 1930, where a group of biologists went around to all the sable farms in Russia, in Siberia, and they selected 8 pairs of the most tame sable. Sable are the black foxes. And they separated those 8 timid pairs of timid black foxes away from everything else and kept them together with themselves. So there was 16 sables, the most timid, the most friendly, the most gentle. And they set them and they reared them, and they grew by themselves. And over a period of 3 generations, those sables, they changed. They physically changed. Their black fur, some of it was spotted, some of it got short. They grew big, they grew small. They altered themselves, and that's how they produced dogs, it was said. And so this was an experiment to just to prove the interbreeding of the species. So there's I guess a little scientific misnomer there to say, yeah, this is how it was done. And our people understood about the interbreeding of species.
So if you're not familiar with Wilfred Buck is a renowned elder who also is a scientist. And so his leaning back onto what science also says is to try and interweave both the stories and the legends that live amongst his people with the science that lives amongst us, right? So there's 2 sides to this. He's a fascinating person to listen to, and you can also Google him. He's got lots of free sites that he has different legends and stories on as well that you can access. Oops, sorry. So in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So again, as I mentioned, we're going to go through and just touch a little bit on some of the previous things. So bear with us for those who may be a little bit new that we might be watching this later. So I'll turn it over to Ted, and he's going to get us started.
Thanks, Chris. Just a quick review of where we're at with the new science curriculum. Just using a bit of a representation of what the old curriculum looked like compared to the new one. And we use the image of a silo to represent the old curriculum. Because if you recall teaching that old curriculum, if you're piloting or implementing this year, we had various units at each of the grades in science. And those units were based on topics. And the topics were ones that we taught and moved on to the next topic and moved on to the next topic and so on. And there was, unless it was purposefully done, there was little interaction and movement between ideas and concepts from the different silos or different topics of information. Our new program of studies, as we know, is a bit more fluid. There is some interaction and moving around. And the foundation part of that is the organizing ideas. We know that from K to 6, there are organizing ideas that are shared, such as energy and matter and earth systems. Some are not shared through all the grades, like living systems. That's not in kindergarten. And space is only in the elementary grades from grades 4 to 6. So just that organizing idea and then talking about some of those concepts, just having that automatically creates some movement and connectivity between all the grades. But besides that, we know that within each organizing idea at each grade level, there are many skills, understandings, and knowledge pieces that flow in and out of each grade. So for example, in kindergarten matter, we're introduced the idea of properties, but we also that also flows into grade 1 and 2 and other grades. And things like senses is introduced in earth systems in kindergarten, but it's also used in matter, and it's also used in other grades as well. So those understandings and skills and concepts move from grade to grade as we move along. So that gives a lot of greater depth to what we could do with our students as we move forward with them. Taking a look at this particular organizing idea of space, we revolve again around that learner outcome and specifically the guiding question that narrows down what we study in space. Space is a broad topic. In grade 4, we looked at more what do we observe in the night sky with a focus on stars and constellation. In grade 5, we're taking a look at how astronomical phenomena are observed and interpreted. And so what we're doing, investigating and interpreting astronomical phenomena. In other words, what we see in the sky and ask what's happening, what's going on there. In this particular organizing idea, students, as we know, need to know certain things. There's that conceptual knowledge. There are certain facts, which are objective, verifiable things. Their names, their events, those kinds of things. And of course, there's some knowledge in terms of procedures, such as how to conduct an investigation, how to compare, and so on. So those are all the knowledge that students accumulate as they go through these different organizing ideas at the different grades. Specifically in grade 5, in terms of the knowledge or the conceptual knowledge, I'm going to go back to grade 4 because you're going to see a building happening here. In grade 4, as I mentioned, the focus was on objects in the night sky, and specifically stars. We can see down in the middle, we see the word object there, and then how those objects in the night sky impact our daily activity. We add on to that in grade 5. Go to the next slide. We see those objects, as they move around, they can create certain astronomical phenomena. In other words, we see an event happening in the night sky based on those objects. And those events in the night sky can be representations, or not in the night sky, but in outer space. We can represent those phenomena. And we are taking a look at a variety of examples in grade 5, such as aurora and the solar eclipses and seasons and so on, and taking a look at what is happening in outer space that affects us here on Earth. And when we get to grade 6, we can see that building nature of the new curriculum as well. There's a lot happening there, but we moved the word of objects in space we add the word celestial objects. And we add on to those, you could see beneath celestial objects are stars, planets, and moons. But we're adding on other celestial objects when we get into grade 6, such as meteoroids and comets and so on. And then celestial bodies, they're taken a look as components of a system, and that's the solar system. And so we use our knowledge through technology and exploration of how that solar system works and how things interact. We also take a look at, more specifically, this is where we look at the characteristics of the celestial bodies. We look at their size, their shape, and their composition, and so on. Once again, just a graphic to say how the new science courses build on each other with their knowledge and understandings. But not only do they build on with their knowledge, but they also build on with their skills. Now, we'll go to the next slide to show that one. What I have here is on the left-hand side are all the skills procedures that are mentioned in the skills and procedures statements. They're aligned by frequency, and I've highlighted sort of some of the top ones. You can see that discuss, compare, and investigate are the top 4 there. We also have examine and so on. That is very similar to the list when we take a look at grades 4 to 6. We see discuss is up there again, compare, relate, investigate, and so on. The reason I'm bringing this up to you is because sometimes some feel stuck to just use that verb that's in the skills and procedure statement and forget that there's other verbs. And I think what we need to do is remember that all these skills from grades 4 to 6 are important. And unless we find opportunities for students to practice those skills, not just what is stated in the curriculum, but to move beyond that, we're going to not have students will get better at them. So for example, if we were to take a look at representation, in grade 5, there's 4 chances for students to represent. And from grades 4 to 6, the skills and procedure statements say represent something in all those 3 grades, just 9 times. Representation is a really important skill for students to demonstrate what they know and understand. And so perhaps maybe there may be times when we want to include that more than what's listed there. And I'll show you what I mean by that on the next slide. If we were what maybe not. I might have it on the next slide. Just go to the next slide because I want to talk about scientific methods as well.
There we go.
Okay, we'll do that right now. I'll come back. Hopefully that other slide is in there. If not, then I'll put it in. We're talking about skills and procedures. We have to look back at the scientific methods organizing idea because there's an important list of skills and procedures there that I think are meant to move on. We saw that investigation showed up many times as a skill. So what does it really mean? We look at the grade 2 scientific methods curriculum, and you see that on the bottom left that outlines the steps. And you see the yellow arrows on the bottom mean that those steps are also used in grade 3, grade 4, grade 5, and grade 6. And the scientific methods organizing ideas for grades after grade 2 builds on those steps. In grade 4, for example, we build, if you were with us yesterday, we build on that step of data by taking a look at data a little bit deeper, by identifying it as descriptive and quantitative, or descriptive data, quantitative data, qualitative data, and so on. In grade 5, the scientific methods builds on the planning the investigation. It introduces something called the controlled experiment. So we're talking about variables. That's just part of the planning of an investigation. We're not going to research. We're not going to test something. We're going to actually do an experiment with variables. And then grade 5 also expands on the whole idea of using evidence and the communication and importance of, sorry about that. My phone's not at silent. So you can see that we've got to bring in those skills as well and keep them in mind as we move forward through this organizing idea and all the others are organizing ideas as well. Besides scientific methods, we also have the skills that are introduced in the science or computer science component. And very quickly, we'll take a look at that. When we take a look at skills from computer science, that whole notion of making and following instructions is introduced in K-1. The creative thinking skills and is introduced in grade 2 and is taken a look at in grade 3. That's things like brainstorming, really being flexible in the thinking, think of as many ideas as possible and that kind of thing. And as well, computational thinking is introduced in grade 3, and I'll get to that really shortly. And design thinking in grade 4. And design thinking is carried on in grade 5. I just want to take a really close look at what they mean, just so that you can see how these skills are not just meant to be used in computer science, that we use them all over. For example, when we're breaking a task into smaller tasks, when we're using computational thinking strategies, we do that often, whether we're writing, whether we're planning an investigation, and so on. So how can we break this down? How can we just choose the relevant parts of things and not get distracted by the small details? That's abstraction. What are the patterns? What are some similarities and differences that can help us move on? Again, we often look for similarities and differences in many things, whether it be cycles or environments and so on. And then we're talking about designing instructions. Well, that's where we go, designing steps through algorithmic thinking. And if things don't work, how do we debug? And those are the computational thinking skills. There's a link there that will take you to, we won't go there right now, I don't think, Chris, unless you think we should.
Okay.
Let's go to that right now. With each of these computer science components that I'm going to share with you here this afternoon, that link takes us to something called the curriculum planning and assessment resource, or the CPAR. And they're quite similar to what you may have seen in language arts, that maybe what you've seen in math, and you will be starting to see in science, and now computer science. And the front end just has a bunch of links to things that we've already created, such as the numbered outcomes documents, concept maps, planners. The presentations that Chris and I have will often be linked in these as well. I don't know if they're linked in this particular one, but links to other curriculum, or excuse me, computer science items that we'll find on the front end that are sort of global in nature. And then the next pages go down into the more specific cusps. Here we get into the organizing idea for this particular grade, and if possible, some summative assessments are identified if possible. Then we break down the individual cusps. We can see at the bottom, we see the I know statements, I understand statements, and I can statements. Those are ones that are taken directly out of the curriculum, out of the knowledge, understanding, and skills. And then they are organized so that alongside that knowledge, understanding, and skills, you can see some sample activities that will help introduce or to help expand on those knowledge pieces, or those things that are getting at with the computer science outcomes. So there's one for every cusp. You could see as we flow along, we're going to get to the second cusp line eventually as well. And so we'll see that one show up with all the cusp statements, and again, a series of sample activities that will help move along the way. And they're in that white center part there. Chris, did you want to add anything?
Nope, that's great. These will be absolutely so helpful to teachers, for sure.
I think so, yeah.
Okay.
So going back to that slide deck, Chris, so there's some skills in there that can be used as well. When we talk about design thinking, it's really problem solving. It's a problem solving approach called design thinking. It's at the end of the day, how do we create something and design it and create that artifact? So we become a creative thinking at the start, getting all kinds of ideas. We plan it, we create it, we double check it by analyzing it, we test it, and we troubleshoot. And we could do that whether we're doing coding in computer science, or whether we're making a project or making a diorama or making another artifact such as an instrument or something. So those are all that design thinking. Those skills are also important when you can think about the application through many things, right? And there's some applications that we see in the bottom corner. So not design thinking is not just there for coding, it's there for other projects and other potential things for students to do. And when we get to grade 5, that's expanded a little bit more in grade 5, and we're introduced to coding specifically in grade 5. And the reason I introduced all these verbs and sources of verbs from computer science, this is the slide I was looking for, Chris, computer science and scientific methods, and that whole collection of the verbs from 4 to 6. That sometimes we get, like, as I mentioned, stuck on just doing what's in the curriculum. For example, in this particular organizing idea, one of the existing skills and procedure statements reads, identify astronomical phenomena that occur cyclically. We can deepen that by saying, well, let's investigate astronomical phenomena that occur cyclically. Now we're not just identifying, we're getting deeper. Students are going to have to do some research, maybe ask some questions, maybe find out, maybe test what their hypothesis is, why eclipses occur, why do the moon phases occur, and investigate that through an investigative process. Or we may we can add that design thing, design a representation. So while those verbs are not in the skills and procedure statements that you'll see in the curriculum guide, I think we still have it available to us to use those skills, that skills list, and provide activities, whether they be assessments or learning activities, to help deepen student understanding of those things. And finally, we have those understandings. There's one understanding in this organizing idea. I think, Chris, that from 4 to 6, this might be the only cusp or organizing idea that has one understanding.
Exactly.
And the understanding is, again, takes those key concepts and put them together in some meaningful way. And when you read the curriculum for grade 5 space, this organizing idea, you'll constantly see constant reference to interpretation, observation, daily living, and astronomical phenomena, because that's what we're looking at. If we go to the understanding on the next page, Chris, putting them together in a meaningful way, the understanding states. And what we're looking at is how observations and interpretations of astronomical phenomena can inform daily living. So when we talk about planning for this organizing idea, as we have with all of them, we're going to begin with the end in mind, which means, well, how am I going to assess some of these things? And so I put forward a possible summative assessment, not just for the entire organizing idea, but one that might help you provide some feedback and information on whether students can compare and their knowledge of interpretation, observation, and the connection with astronomical phenomena and daily living. So might get students to compare the indigenous interpretation of aurora to the Western science interpretation of aurora, and then explain whether the comparison supports this understanding. After comparing those things, it's true that observations and interpretations of astronomical phenomena inform daily living, and if so, how? In order to do that summative assessment, you can see that we've got to go backwards and unpack this and say, what do students need to do and be able to know and understand in order to do this assessment? And that's where we look at the phases of learning. So we do our pre-assessments of our concepts. Do students know what astronomical phenomena are? Do they know what an observation is? Do they know what a comparison contrast is? And can they do that? So we find that all at the surface level and teach to that at the surface level. And then we start putting those things together. You know, what is the connection between our observations that we make, our daily activities and astronomical phenomena, and our interpretations of that? How does that affect what we do in our daily lives? And we provide different and variety of contexts. And I think we'll see the variety of contexts show up with the different astronomical phenomena, such as we explore that understanding through eclipses. We can explore that same understanding through aurora and so on. So part of that surface learning is also the some of the ideas that were introduced in grade 4. And Chris is just going to do a brief summary of some of those big things that were introduced in grade 4.
And I think it'll be important to find out maybe what they do know. That pre-assessment will be really important, is what is their background knowledge in space? Because remember, space used to only sort of live in grade 6. And I think students love it. It's a topic that they love. So we have to make sure that we have some understanding of where the kids are coming from. They may know a lot more than we give them credit for, but they may not. I mean, they may even know what an aurora is, right? If before I launch into some kind of conversation with that, let's find out if they even know what an eclipse is. Do they know what an aurora is? Do they know what the aurora borealis is? I mean, they might notice the northern lights, but not know it from the science side of it. So again, it's that pre-assessment of how you're going to unpack this unit. Some of the things that they did in grade 4 would be helpful. There's no question about that, knowing what they do know and what they don't know from that. And so remember that they were looking at in grade 4 how objects in space impact their daily life. So what are some things that for example, I see stars at night. I see stars, I know it's nighttime. And nighttime brings on a whole different demeanor of me than it would during the day. And if the sun was out and if I was doing kind of activities. So just that kind of subtle little difference between day and night having an effect on my life would be something that we could talk about just to get going. So a couple of things that we suggested could happen with the grade 4s would be that pre-assessment. What do they know? So remember, I'm just picking a couple of the slides from here. You've got a whole slide deck from grade 4 that you can go and grab if you need something. But just asking them to make a list with a partner about what are advantages and disadvantages of exploration in space. Like, whoever thought that we would be out there, and what do kids think? Why do they think we're up there? What do they think some advantages and disadvantages? And that will really help us to really understand, you know, are they into this and have they heard a lot already through media, reading science journals, like whatever their interests are. And there's going to be students, this is a big area of interest for them. So having that kind of conversation with them up front. Naming some terminology that would be key to space. What is a universe? I mean, that gets defined with them in grade 4. But again, they would need to know some of that language before they come to grade 5. So again, there's some backstops here that need to happen. And then again, recognizing that the universe is everything. It's all of us, the stars, the comets, it's everything that's in there. It's the big umbrella. And that was the example that we gave yesterday is grade 4 opens the big umbrella and looks at all the things that put the big umbrella together. But we don't get anything deep. We don't get into the specifics of the planets. We don't get into that. All happens in grade 6. So it's very much just looking at the canvas that makes the umbrella, what puts it all together, and then grade 5 and 6 really start to unpack some of the specific technicalities of each of those pieces. Having them even just do a wonder and a notice type of thing. So what are some of the objects that they see in the night sky? And it might be during the daytime. Obviously, you're asking them in class. So what do they recall when they look up at the sky? What do they say they see when they would look up at a night sky? And then what are some questions that they might have about that? So we even had the discussion yesterday about, do your students know, or have they ever been shown what it means to notice something? Do they know what it means to have a wonder? They might have only ever heard a wonder as in, I wonder if, I wonder if, I wonder if, I wonder if. But I wonder has a lot of other possibilities and adjectives there. So I wonder what, I wonder who, I wonder when, I wonder, or wonder that something else happened before. So perhaps giving them some writing prompts or question prompts helps me to be a better questioner of the things that I'm looking at. We also suggested perhaps using an infographic, not saying that's the only thing you could do here, but if you want to break it up a bit and haven't done one before, it really requires students to be a little bit creative, but it also, the advantage of it too is that they have to be succinct in their thinking. It's not pages and pages of writing here. It's let's get to the meat of the matter and how concise can they be to get that information across to their peers that are in their classroom. So again, there is a slide deck to help you with. Never done an infographic before, don't know what it is, don't know what it looks like. So again, these will help you through that. Again, there's slide decks behind there to help you to work with the students. But also remember that I don't want to learn how to do an infographic while I'm learning about auroras. I will need to know what the infographic is so that as I'm learning about an aurora or an eclipse or whatever you want me to learn, I already know kind of what I'm going to have to frame out for information. So doing that from the perspective of something that's easy and simple for them, something that's in their head already that they can learn to take a very familiar topic like how to make the best sandwich ever, or what do you do at recess, what don't you do at recess, or whatever. I mean, whatever you decide, if you've got something happening in your classroom or school, could they make an infographic and learn from that as to how to put it together before you ask me to start putting my understandings of science in? So it's that trial run, right? Learning to do that. And again, the wonders. So they might have said, I see the moon, I see the sun, I see planets, I could see planets. How could you see planets? Well, I can't see them very well, but I do know that some of those big brighter stars are actually planets. So we also then, well, then how might we see them? How do we get some of the pictures that we have? So talking about what tools are available for us to see the things that are up in the sky. So we unpack sort of the use that you could do binoculars. They offer us a fairly lay person's ability to look up at the sky and see things quite more clearly than we would if it was just the naked eye. I could use an observatory, a telescope. Obviously, they have stronger ones, smaller ones, but again, a suggestion was, do you have anybody in the class who has a telescope? Because astronomy is something that's very mind-boggling for lots of people, but a keen interest for them. So maybe you have a parent or two that already has one and they'd like to have an observation night with the students. Knowing where you live and what's available will make a difference too, because if you're in a big city, that light pollution that you're going to have is going to bar them being able to see all of the things in this night sky that we're hoping that they could, versus if I'm out on a farm, I have no lights outside and I look up at the sky, very different look for sure. So again, what would they see? Would you be able to take them to a TELUS World in Edmonton? Would you be able to go to the Spark Center in Calgary or something similar to that? And if not, and we know that we can't do that a lot, there were lots of possibilities that we showed in the slide deck where you could actually do interactive types of looking at the night sky. So I don't have to leave my classroom in order to get the idea of what happens in a planetarium. So stars and constellations are recognizable. Do they know what a constellation is? Maybe they don't, maybe they do. Maybe they don't even know anything about them. Maybe they know some of them from their birth month or whatever, if they've been following that. So again, it's that pre-assessment of what do they know and what don't they know. There is a resource that I shared yesterday, and that resource would now go further. I left the grade 4 one in here so that you could see what grade 4s would uncover. And it's just a very small component of these resources. It's not the majority. The majority of these actually live in grade 5 and 6, especially the astronomy space systems. That one is really quite tailored to grades 5 and 6. About half of that would belong to grade 5, and the rest of it for the planets and all the information that we talk about there would be in grade 6. So this you can see, I left these on so you can see what the grade 4s would be doing. But I just want to clarify, there's two different resources here. These resources you have access to, and you are allowed to photocopy. There is no restriction on these. These are freeware, and you can edit if you so choose. I have just hyperlinked the tops, and it takes you to the same place. I'm just going to take you to one. I'll go to the one that you're likely to go to. There are 3 sets of resources that come with each one. So it tells you the curriculum is for free. This gives you a descriptor of what is in that particular unit, especially as it links to grade 5. And when I say go to the bottom, here's what I'm referring to. If you go down to the very bottom, you will find that there is a student reader. And the student reader, I would not say photocopy the whole thing. Go in it first and see what you want. Maybe you only want 2 or 3 pages, or screenshot some of the images in there and just use those for your own slide presentation. But the student readers are generally about 26 to 30 some pages. Very well done. Short snippets of the information that we want them to learn. Still allows me to get my attention to it, but I may have to do some further research if that's one of the areas. The teacher's guide is very detailed, and they're usually 150 to 250 pages long. So I would suggest also looking in there, because they provided activities, they provided sometimes slide decks that go with it. They've provided assessment questions. So there may be some things in there that you can leverage depending on how you want to organize your unit, right? This is not the unit that you necessarily would do. There's one for, you always want to go with the free download, because that way you don't have any cost associated. And then the online resources are just that. They would be slide decks. Sometimes they're visual images that they referenced in the teacher's guide, or they're the activity sheets already done for you. You just need to pick the one that you need and you photocopy it. So you go from there. So it just gives you a bit of another place to go for a resource. This one is a different one. This is this book here. But again, it would offer some things on constellations that we could talk about if your students don't know something in that. Okay, so just so that you know what those resources are about. Ted, do you want to talk about this page? Because this is an important page.
This page is just a list of activities you may want to do if you know you're going to be working with students and introducing or using some of these concepts that you see here. For example, quite often in the curriculum, and if you recall from the list of the skills that I shared with you, relating is an important one. So what is a relationship? And quite often we represent relationships through concept maps, for example, and cause and effect relationships, dependent relationships, and so on. So what this page does is provide some introductory, and again, that surface level activities, because that surface is where we're introduced to some of these ideas for the first time and work with them a little bit. So this is one way you may want to introduce these things. When you take a look at them, you'll see, well, this can be used at any organizing idea and so on. You're right. These are sort of broad level concepts that are on here. and introducing them that way. So take a peek. Quite often they're more honed to younger kids, but they can be used as a springboard to develop or add on to make it more age appropriate if you want. So feel free to look at those. They can help along the way, especially when we're moving through not only this curriculum, but the organizing idea, but other ones as well.
And as we kind of unpack again, I know it sounds crazy about next year, but as you start planning for next year, once you've had a chance to kind of go through all of the concepts that live in each of these organizing ideas, you might want to go back to this page and see where you're going to strategically infuse some of those, especially if you're going to redo some of your units the way they were done. This gives you a chance to go back. And I'm pointing that out because I did a workshop with a group of teachers I've been working with the whole time as well. And we talked about Notice and Wonder, and they said, well, where did you get that slide deck for Notice and Wonder? Now, we've been sharing this kind of a page since day one with all of the grades, with us included, 4, 5, and 6. So in each of the organizing ideas, there's always been this kind of a sheet with the blue lines on it, those hyperlinks. So go back and have a look and see if there are places that you could infuse those in to do that understanding and that teaching that happens. The first time round, it's like find everything we've got. The second time round, it's a chance to start to organize all the things that we have and find the holes, the things that maybe we didn't get the way we wanted it to go the first time. So,
Sure.
right. Just a challenge again that we threw out to students: develop an infrared telescope, because they were talking about telescopes as tools. And if we were going to go and get some of these pictures of galaxies that are so far away, but definitely can't see them just from looking at a telescope on Earth very clearly, we have taken telescopes out in space with spacecraft to get them out further and then send them on their way. So in this case, this was kind of an extension of them understanding. It was like a design activity for them to design, just using cardboard, how you might create a cover for your spaceship so that the radiation isn't impacting it, right? So a little bit of work that needs to happen there. But it just gives them a chance to do that design thinking as they're going through. We talked about this book being one of the good ones for grade 4s. It's a great one for grade 5 if you want to just kind of intro the stuff that we did in grade 4. It's an epic book, so you don't have to buy it. You can just go online and read it with the students. But it has some great connections between art and math as well. It's not just the science pieces, and it introduces a lot of those components. Looking at what are some sources that we could look at for the telescopes for using binoculars. So there's lots of resources here. And remember, we're not in any way suggesting that you would use everything here. It's a matter of, are you giving them choice? And then you might give them a couple of links to go from, or are you going to do some things as a class and then they're going to break off from there? So again, these are just tools for you to refer to. We also talk about night and day. And so we asked them to consider what would happen there without getting into all the technicalities. We're not talking about, the deep understandings of where we are in position to planets and this position of the sun. But again, it's that umbrella that we've opened up, right? So talking about what would they see? How did they see the path of the sun even moving during the day without glaring at the sun, obviously? How does that fit when it disappears? Like, why does it go away? Where does it go, right? And where did the moon all of a sudden come from? And why don't I see the moon every night? And why does the moon look different? And then we unpack the moon big time in grade 5. So having some knowledge of this from grade 4 would be helpful. This is the planisphere that I was talking to you about. So if you can't take the students out to help them understand the different hemispheres, to understand that as we go through a year cycle, how things can change. I don't see the night sky the same every night in every season. It doesn't look the same. So you have some flexibility here so they can look at some of the constellations. And as we move this, we see how things can change and how the Western Hemisphere is seeing something different at different times of the year. So again, this one gives them a lot of choices to be able to see. You can enlarge this as well. And then Polaris, the North Star, is a big one. And if you go through all the Indigenous stories, that's also one that has lots of stories to it. And why is that so important? And why did we use that for navigation and history? This is a great video. So if you wanted something to kind of bring together grade 4, this one shows you what the constellations are. Who ever thought of the constellations to begin with? Where did they come from? So it ties a little bit about historical storytelling into it from a variety of different cultures, not just one perspective, to how and why. It doesn't matter if we live in Canada and somebody else lives in Mexico, we all are using the same names for these constellations. And why is that? Like, if we're not all seeing the same thing and we all didn't find it with our own culture, why are we all calling it the same? So why do scientists find that that's absolutely imperative? So this gets that unpacked, and that is a very informative little video for that. This is another interactive one. I won't go into all of these. So again, it helps you to find the different constellations, and it allows you to be quite flexible in those. These are your connections to story and culture. So what we did in grade 4 also fits into grade 5 here, because you're going to talk about the aurora borealis. You're going to talk about, so how did the Inuit see the Northern Lights? What's the story that the Inuit tell for the Northern Lights versus the Cree stories? Very different, but still very meaningful to them. So these just give us all kinds of different perspectives. This is one again with Wilfred speaking, and he talks about the lunar, and you're going to want to probably watch this, and I've got it in your slide deck several times because this is an important one, and I think I'm going to say to you someplace in your unit you're going to have to show this or should show this. So it ties to the lunar cycle. It talks about why there's 13 moons, talks about the importance of those 13 moons. They even have a name. And if you think about the names as they unpack them, I have included that as a slide deck in there, or as a reference in there. The name of each of the moons is really linked to an animal or a situation that is reflective of what's happening in a season. So for example, the goose moon is typically the March moon when they're starting to come back, or April when they're starting to come back in their flight. So they have a really good connection to that. This is also a telescope for the sky. It gives you an opportunity to go in and put your postal code in, and it'll give you a night sky for where you live. So it's very flexible depending on where you're coming from for this session. And then again, another virtual planetarium. So this one is about 27 minutes long. And it really is, you're sitting back as you are sitting in a planetarium, and you are watching how things happen in a planetarium. So if students never say, I don't even know what a planetarium is, this would be your next best thing if you can't get them there, to go through this, because they can see how it gets maneuvered. They can see how we can zone in. They can see how we change from the northern hemisphere to the southern hemisphere view. They can see the directions on there. And in grade 5 in math, they learn to plot coordinates on a coordinate grid at the end of coordinate geometry. And that means that they have to be able to understand their directions, because prior to the plotting of the points, we talk about, if I went L7, where would I end up on an old map? If I was going 4 to the right and 7 up, where do I end up? What city? Or can you give me directions? Can you show me the rule or the algorithm that you would follow to get to a location? So this fits into this very, very well. So then we get to grade 5, and we want to talk about what is astronomical phenomena. It's a big word, and for some of our students, those are super big. They don't really know what they mean. We want to see how they might get together and understand what that is. But I would ask the question again, does anybody have any ideas about what phenomenon is? Does anybody know what astronomical phenomenon is? And they might have heard the word astronomical in other contexts, right? This is astronomical. They heard it from an adult saying, this is crazy, like out of this world. So how could they link that to this as well? Those are the kinds of things. Ted, do you want to add some things in here?
Not much. It's just that if you do click on the borders of those each of those anchoring concepts. And I call them anchoring concepts because those are ones that keep repeating themselves. They're really foundational for this organizing idea. They should show a link to something, are they not?
Yep, they come up on the bottom. We can go
Yeah, they
into
come up for a link. So if you want to introduce phenomena and astronomical phenomena, there's one. With the daily human activity, that's something that we often, maybe there's some assumptions that that idea shows up from early organizing ideas, but what do we mean by daily human activity? And how is that different than just human activity in general, which is the other slide deck that's there. So again, these are just some that's, as we talked about earlier, some surface level activity. If you're not too sure your students know these things, you can maybe pull out the odd slide out of these slide decks and just use them as a little pre-assessments as well to see if they understand those. There's one for interpretation there that shows up quite a bit, and you'll notice that I have the word draft on here because this has been I don't know, for some reason, a really tricky one to do. But you know, when you look at the learning outcome and the only understanding, we're talking about how observations and interpretations of astronomical phenomena impact or affect daily living. So understanding what an interpretation is kind of important. So this slide deck kind of takes you through that. It'll likely change as we go along, but your link would never change. Your link would be the same. So check back with this one in a couple of weeks. So with this, it's like any other concept attainment activity that these often are in, is that you're given an example and a non-example of what the item is. In this particular case, we've identified the word interpretation. So we have something that's an interpretation of that event and something that's not. Go to the next slide. Again, another interpretation and something not. Now, this one's a little bit more bizarre than the other one. It's not as scientific, but it's still an interpretation because it's something that someone might think of based on what they observed. It does look like something coming out of a whale, so that would be an interpretation. But we would know if we get more information that that interpretation would change as we get more information about our world and what the world is underground. Nonetheless, it'd still be an interpretation. And so we go on, it's giving examples and non-examples of interpretations. And as we go along, then it does define interpretation eventually. And we talk about interpretations, not just events, but we also interpret words and other things. So we define interpretation as the way something is explained or understood. And it's typically based on observations. As we see something, we're explaining it, and here's what we understand about it. Here's the meaning we give it. So after we go through some of those examples, and most concept attainment activities, it's an example, non-example. And then we ask, well, what is being explained and understood? There's a slide deck that explains this before. There's some phenomena, so you could insert the word phenomena. What phenomena is being explained or understood in those slides? Then for the next 3 slides, well, we're asking them, we could do a think, pair, share, and this is something you can get students to discussing. Same one, there was an interpretation there, but now what is ask the students what their interpretation, if they're doing a think, pair, share, we know what they're going to think about it themselves, and then they're going to share it with their pairs and with the class later. So here there's opportunities for them to make an interpretation of either what's happening or what does this mean to them. To have them practice making those interpretations. I threw one in there just because it's one that, and there's a slide deck that shows up a little bit later on where it takes all those astronomical phenomena and asks them to make their own interpretation about it first. So you can see there's different opportunities for their classmates for them to think about and for their classmates to think about. And then it investigates interpretations a little bit more. You know, they're going to obviously have different or similar interpretations. And so what does that tell us? That really, that there's a connection between what we observe and the interpretation. And if that's so, what is there that makes it so? And then to explore that idea of interpretation a little bit more.
And as they do some of that research that we're going to ask them to do, they may prove or disprove some of their interpretations, right? And that's where we go from. I just want to point out too, that just in case you hadn't been part of one of our conversations before, when you see this blue box, if you want anything that we have in the slide decks, you often will get this blue box come up. What it's doing is letting you preview the entire document. And if you only wanted one page of it, all you have to do is just click on that blue box. It will download it to your computer in an editable form. So you can remove what you don't want to use, you can add in what you want, or just use it the way it is. But it doesn't come as a PDF then, it'll come as a form that you'll be able to go in and edit. So just so you're aware of what those blue buttons were.
And just as an example, when we were, Chris had me speak to that other slide deck that had all those list of blue links. Those are their short little activities. They're set up very similar to this. Most of them are just slide decks, and you can just click through. And as Chris said, you can edit them later on. So they're not too huge. We know at the surface level, if we're going to have students do some things, if we know we want them to compare, we want to make sure at the surface level they do that. So there's some information on what is this comparing. There's some skills and procedures they're asking students to relate phenomena to human activities. So what does it mean to build a relationship? We can best demonstrate that by concept mapping. So there's an introductory surface level there. When it comes to interpretation, that just gives students a chance to interpret the astronomical phenomena that is being investigated in this organizing ideas. So they can make their interpretations, and then they can do I used to think, and now I think type of activity after that if they go through that slide deck. So
when we're talking about astronomical phenomena, at some point we need to get there with them. So what is it, and what are they, and what would they be looking for? So they're just observable events that they can see among objects in space. So I can see that the moon rises or comes up at night. I see the sun comes up. I see that sometimes there's a shooting star. I see that stars have patterns to them called constellations. I see that sometimes I see something tracking through the sky. It looks like it's a star, but it's really moving fast. So that could be a satellite. So those are all what we would call astronomical phenomena. A meteor, a comet, an aurora borealis or northern lights. Those are all examples. So any of these so-called events that we can see could be identified, and sometimes they're predictable. They come in cycles. I know when it's going to happen. So when we talk about the moon phases, eventually we're going to talk about tides in there as well, because that's linked to it as well. And I mean, if I'm a fisherman or I live by the ocean, I know when tides come in, I know when tides come out. It's all recorded, and certain things impact life. When the tide is out, I can go out and walk out, and I could usually dig up clamshells and whatever I need. And then when the water comes back in again, I've got to wait until tide goes out. So that impacts life directly, even in this case for food. Seasons is another one. Those are cyclical. And they do seasons in a number of different times of the year, but they do them in grade 2 in particular. So it's not new to them, but the cycle of those seasons, and it should be obvious now by a grade 5 student that there are certain things that happen in those seasons that impact our daily lives as we move forward. How do the seasons come about, right? So now we are going to get a little more technical than we did in grade 4. We are going to talk about the Earth's revolution. And we're going to talk about it moving around the sun and the fact that it's tilted. So we're going to talk about that and how that affects my day and night, and how does that also affect how much sun I get at different times of the year, which also affects the season that I'm in. And that varies from where we are in the world as well, right? They need to understand the different hemispheres. They're not going to be exactly the same. So we're talking about white winters and white Christmases, and the colleagues that I have working with me in New Zealand, they always laugh and they say, who would want a white Christmas? Like, we like our green Christmases. So they're the opposite, right? And we couldn't even fathom how that would work. But I also work with a group in Mexico, and for them to even understand what 4 seasons could look like is beyond, because those children will never see 4 seasons. It's never going to be the way that they would see it here. So again, those seasons, the length of day and night, some of those events will include auroras and eclipses. They're to know what those are, but there may be other ones that they're interested in. This is a good time to get their keen sense up, and what are their interests and where do they want to go with that. Some of those events are predictable, and because they're predictable, that's how we started to get calendars. How do calendars get lined into, let's say, the moon cycle? And that's one of the ones that Wilfred talks about. How do cycles, period, just get predictable? So cycles of tides, right? That's another one. Stories and legends. The stories and legends that are held by other cultures also not just tell the story, but typically are also tied into some kind of a cycle of time in which they appear, in which they don't appear. So those become parts of how people would track time, track long cycles of time when we didn't have watches and we didn't have media to tell us what was coming. Models, digital simulations, all of those would be pieces that students should be able to access in order to verify some of these events that they're going to do the research. I don't know that we would do our students justice by just standing up and delivering this information. This is a really golden time for them once they've kind of got some of the basic understandings of where we want to go. What do they really feel is their interest, their keen areas of interest, and let them become the experts on that. Whether they do it through an infographic or whether they do it some other way, it doesn't really matter. So again, then what are your interpretations? Do we want to go into this one or not so much, Deb?
No, actually, we don't have to. That was the one that had all the phenomena that you listed there and gives students a chance to make their own interpretations before we dig into them and get a
Well,
more scientific explanation. So
let's have a quick look at it so that you can see. But again, this is one of these units now, 5 and 6. I really think that students really need opportunities for choice here. Once they get the basic understandings behind them, they need to kind of understand where that goes. So one of the live sites that I showed you for star science, also depending on where you live, if you look in the bottom right-hand corner, it will say how many days until the next eclipse. So it will track it for you wherever you live and wherever your location is. So again, that might be something that students want. There's one, I think, in 63 days or something. There's another eclipse. So something that students can see and actually live through. We don't always get to see those things, right? How are the moon phases? Why do they look so different? Why are they never looking the same every night? Okay, why are tides in, tide out, that kind of thing. So yeah, these are great pictures. These are awesome.
yeah, and then afterwards, of course, it might be a nice assessment at the end to do I used to think and now I think. So, or I used to know and now I know.
You bet. Okay. So again, I'm also an advocate of not necessarily telling you anything. I sometimes like to just watch a video and then ask the students after the video, what have we learned? Right? Instead of me saying seasons come from, maybe I want them to watch how the Earth's rotation and revolution works. And what did you learn? We learned that, oh, we got seasons out of that. We learned that there's something called the Northern Hemisphere and the Southern Hemisphere. What does that mean? So we can unpack, and certainly we can fill in some gaps in their understanding as we come out of it. That's just a thought. I mean, I'm not saying that's the way it has to be, but some questions that we might ask the students either prior to or after watching it, right? If you want them to go in blind and just watch and learn and listen, sorry, these are going to want to act up here. Could they model day and night? Okay, and that's what this is gives them an opportunity to do that representation that we talked about, that how do they represent, what way could they create a representation or a model of what day and night would look like with something as simple as a pen, let's say, and 2 styrofoam balls and maybe a flashlight, or the seasons. How could they use a foam ball and to try and understand how different parts on that would work as far as the seasons would be related. Some students might do this with a globe. If you have the fortunate piece of still having a globe in the classroom, because there aren't a lot of those around anymore, how could they leverage that and just use a simple light to show how the seasons, day and night, would come together, right? It's just how would they unpack this and letting them just explore and go through those. This comes from a resource that's on the next page as well, or sorry, it is going to be on the next page. But this is one on seasons, and this one talks now about, this is after the fact, so if they already know this, I wouldn't worry about these 4 pictures. This one just gives them the image then of how does that tilt actually look, that 23-degree tilt that we live off of, and where that goes. And there's a link for Let's Talk Science. You'll find some down here for PBS. If you have not subscribed to PBS as a teacher, it's free. They have a wealth of information for us, especially when it comes to space. But in every organizing idea for every grade, they have got a wealth of videos that you could use or allow students to watch if they're doing a little bit of research. So some questions that we might ask them, you know, what is the relationship? As Ted talked about, we need to make sure they understand, what does the word relationship imply between the Earth's tilt and experiencing the length of a day, right? So they could maybe talk about that in their model, or maybe that's just a question you're going to ask them. Maybe they could take a flashlight and a basketball. I mean, I wouldn't necessarily always tell them what they could use. I think I want them to be able to be creative enough to come up with their own design and see where that looks. And if it doesn't go well the first time, then you learn from that and change it. So do the Northern Hemisphere and Southern Hemispheres experience opposite seasons at the same times of the year? If it's summer here, is it winter there? Right? Having that conversation. Relate the terms equinox and solstice. They hear that a lot when we go from spring to summer, summer to fall, fall to winter. Like, what does that mean? And where does that occur? Rather than me just telling you, why don't we just do a little bit of research now that you know there's something about a tilt on there? How does that play into this as well? Okay, Ted, you want to talk about this one? Concept maps.
Yeah, trying to find my unmute button. Yeah, this is just we're talking about deep strategies. Remember, that's where we're bringing all those individual concepts together in some kind of a meaningful relationship. And concept maps are often a good way for students to demonstrate what they know, or even a formative assessment to know how they know what the concepts are and how they're related to each other. And so an example would be giving students just little pieces of paper with these words on them and having them organize them into some kind of a meaningful concept map. When students are introduced to concept maps, they know that anytime there's a line connecting one word to another word, there's a relationship, and they have to be able to demonstrate that relationship. And so the next slide shows what that concept map may look like, for example. Then I would ask students to, if they organize them like that, I wouldn't just accept that. I would say, explain to me what your concept map is, like talk me through it to say what the relationship is.
And that would be
So
something, when you gave them the cards, what we have found with even the younger students is we just take some of that rolled paper that you have, you know, the newsprint kind of paper, lay it out on the floor, let them do it, and then they can draw their lines to connect things, and then they can talk to you about it, because not everyone's going to have the same one. So just having it on a piece of paper where they can draw and make connections would be good. So moon phases, that's another one. So they need to be able to explore, how does the moon change? Why does the moon change? Why does it look different? What do we call those different phases? So again, this is another one where you've got some relations to this. The moon in Indigenous sky lore, this is where this picture comes from. But there's a lot of stories there about the moon. They talk about the different moons. This is where Wilfred would also talk about the 13 moons. So this is an important one for students to kind of unpack as they're going through. Here is the 13 moon story, and you're going to see this one again. And here is the technical, the scientific side of the phases of the moon. So why is it that we don't see the same thing every night? And again, it goes back to their understanding now of the tilt of the Earth and the rotation and where the sun is and where we are in relation to that too. That's all part of it. So this would be something that we could unpack, or they could unpack, whichever way you want to do this. There's a couple of videos that you can access here. And this one is specific, just very technical, but very good about the phases of the moon. So if you wanted them to actually draw them, they could do that as well. Remember that this is also from the old grade 6 curriculum. They did do that in there as well. So that would be another place that you might want to grab some resources from, but not necessarily really wanting to go straight to worksheets, right? Here's a nice little questionnaire of, if I've done the moon, I probably have talked a little bit about tides, and this is just a brief introduction of what that is. And in this case, it gives them some prompting questions. So maybe they want to do a little bit of research. Maybe you want to give them a tidal time card so that they can see when tides come in and move out, and so that they learn how to read them, and then they could answer some more of these questions. So again, it just gets them to think a little bit more deeply. So the what do you think is a great one for them to answer some open-ended questions. So it is just an exploration kind of questionnaire that they might be able to use. It comes out of this book here, which is where I got the other one from as well. So this is the grade 6, one of 4 grade 6 science books from Newfoundland and Labrador. We had asked for some of the books that are being used across Canada to be shipped to us so we could see what was in them. And their space one, this is what this unit is, it's called Space, is a beautiful match for what we do in Alberta for both grades 5 and 6. There's a little bit in there for grade 4, but this is really a great combo for grades 5 and 6. So that's where we took that from, just so that you're aware of it. The lunar calendar, once I know about the 13 moons, we often hear there's a lunar calendar, and sometimes navigation at sea still uses a lunar calendar as well. There are lots of Indigenous cultures that live by the lunar calendar at the same time that they are using our Gregorian calendar. So do students know that there's actually 2 different kinds of calendars? There's a whole bunch of different ones, but these are the 2 that would impact them. So here's one that talks about the lunar calendar and how does the moon help us make our calendars. But then here's also one that's the Gregorian calendar, which is the one that we live by for the 12 months of the year. So again, that's another piece that you want to put in there. Talks about cycles. These are, again, this is the same one that we talked about, the 13 moons, that you might want to revisit that once they've talked about and learned about the 13 moons and they've talked about cycles. Maybe you want to come back and watch it again. Here's the full story of all the 13 moons. So if students are going to unpack a little bit about what are the names of those 13 moons, ask them to pay attention to the names and how does that link into what they've learned about seasons? How does that link into the times of the year that's being reflected? So again, or how do people use both solar and lunar calendars? There are people who use both. How? How do they make that work? So we know that traditional Inuit knowledge, First Nations knowledge, has always done storytelling from the stars. And the stars are also part of the creation story in a number of places. So we have to recognize that that is encompassing of not just Mother Earth, but how Mother Earth comes to be. And again, that would be helpful for them to make those connections when you're looking at the First Nations pieces. That ties into things like what's an aurora? What is the Northern Lights? What's the legend behind the Northern Lights? They've actually given you 2 different ones because they're not the same. It depends on who's telling the story. So the Inuit culture has a slightly different one than other cultures would have. So one talks about the salmon swimming, one talks about the bear. So again, just watching one or both and having students make that comparison. This is your technical from NASA. What are the Northern Lights? How do they appear and where do they come from? Again, here are some of your First Nations cultures. That's a repeat of the first slide that I showed you, but you're seeing this one come up. So at some point, I know it sounds like a broken story, but that's really one you need to tie into grade 5 for sure. Okay, let me see if I can get past these without them turning on. Whoops. So again, many connections to space, stories to space. How do the constellations get scientifically named and used? But then how do we also name them from the stories that come behind them? So what are the legends that are related to astronomical phenomena? What have they heard? Some of your students might already know some legends that go along, and maybe they're willing to share them. These are stories and legends of star constellations and of particular ones that are important to navigators. And that's an important piece that comes from grade 4 into grade 5 is how does that work when I didn't have clocks and watches? How did I navigate the waters? How did I use that? So not only did they get their names, but the stories are also helpful in understanding how they navigated the world. And then you have some additional resources depending on how you unpacked your unit. If you need more, there are more here. I'm not suggesting that these would be all ones that you would use. You're going to kind of add these in as you go along. Okay. So do you want to talk about the spectrum sort, Ted?
Really briefly, any of these can be used as assessments or as a summative assessment or as a formative assessment. Spectrum source is one of those things that gives you some really useful information on what kids know and understand about certain concepts or ideas. In this particular case, we've got the aurora, and we're asking them to put each aurora on that spectrum to the degree to which they have an impact on daily living. So which would have the most out of those impact on daily living, which would have the least impact, and where do the others fit in between? And then listening to their conversations. And again, formative assessments rely heavily on conversations and observations. Just by listening to their conversations as they justify the reason they've stored them in their way is a really good indicator of what they know about those particular phenomena. Another way to change an assessment into create an assessment, whether it be formative or summative, is to take the understanding and make sure you hone in on those concepts, because understandings are built out of the individual concepts, but change it into a question. We call that a conceptual question. So, for example, what is the relationship between observations, interpretations, astronomical phenomena, and daily living? And can you provide an example? Or how does this video or case study demonstrate the relationship between these things? So taking the understanding and turning it into a conceptual question, getting kids to take a new context and demonstrate the understanding with it, which was what transfer is all about. And our assessment should be new contexts all the time. Just another example, using and Chris already had a similar one with this, is taking a look at some of the stories and understandings with the First Nation, Métis, and Inuit, and just taking that conceptual question and applying it to that context. So using a First Nations context to explore that question. And
we have multicultural classrooms right now. They all have different stories and beliefs. This would be a great time to bring some of those out, right?
And it goes beyond just the, here's what these phenomena are, where students are, when they're asked those kinds of questions, they're really forced to think about how it's all connected and how these things do impact life, and not only in our culture, but other cultures.
Exactly. This is the link for the Calgary Astrophysical Observatory. This is where I got this from. This is where the Moon and Skylore stories are from as well. But when you come into this link, there is a lot behind here that you can use as a teacher. So there's individual information just on sort of the sky stories. These are general descriptors that you're seeing. The more specific ones come below. And even more so as we talk about how do I use some of the tools, below that here are some of your legends and stories that go along with that. So these are all accessible to you for free. And you have access to going through any of these. You can certainly visit that if you're in a Calgary area, but that gives you some possibilities there for sure. We've already looked at this one already. That's just one of your resources that I'm putting in here. And then we had a couple of Pearson books as well that fit to this particular learning piece again. This one was done by Wilfred Buck and Melissa Purcell. She's from Alberta. And it comes in French as well. So it just gives us an opportunity to have, if you want some in-class or library resources, it gives you some things that you have in here. So this one would be a great one, again, to revisit some of the tilt of the earth and how that affects the different seasons and time of day. Oops, got that in there twice. And then some sources that we had as well. So just to finish up, just a reminder as well, we had mentioned this at the very beginning of starting, that we were going to be doing an assessment section as well. And so there is a 2-day series. It's not back-to-back, where we're looking at building some assessments for grade 5 science. Some of the school boards required teachers in grade 5 to have a year-end assessment, and others don't. Others are fine with just the summatives that you're doing for each of the organizing ideas. So our intent would be in the end of 2 days to develop either a year-end assignment, assessment, or one that fits for organizing ideas. I think it'll be the will of the group and who's there. And what does that look like? Do we want all open-ended? Do we want written response? Do we want them to be PBLs? Do we want some built-in multiple choice in there as well? Like, what does that look like? What does a good assessment look like now that we've had a chance to kind of work our way through this new curriculum? And so those are happening on February 27th and the April 9th. So they're not recorded. This is everybody that's coming, let's roll up our sleeves and we just work together. It's via Zoom, so you're not traveling, but you would have to have the days available for sub time so that you can join in and do the things that we do there. This is the link to register for the session so that you have a sense of where it is and what time it is. So that's kind of that end piece that we have. Although we're done our series, that doesn't mean that you can't reach out to Ted and I at any time if you have any questions at all. There is no reason not to reach out and just say, hey, I was doing something and do you have any more on this? The CPAR documents would also be another document that you want to keep your eyes open for as we start finishing the K to 3s. If we have time, we want to get into those 4 to 6s as